we have a residual plot. Now, if you look at this, I can't find an actual pattern. When I look at this picture, I do not see a pattern in the dots. Because there is no obvious pattern, that means that this model is appropriate. That's it. That's all. Okay? I promise it's not a trick. So this one right here, we have a linear model to describe the relationship between the number of calories and the cost of sandwiches for Wendy's. My question to you is, class, is this appropriate? Do we see a pattern? No. Does anyone see a pattern? I kind of see a pattern. It's giving, like, if you kind of see a pattern, that's the pattern. Okay, it doesn't have to be perfect, but if you can follow it and you can predict where it's going, that means that there's a pattern, right? So I can see that it's going up, and then it goes down. So because we have an upside down U-shaped pattern, that means that this model is not appropriate for what we're looking for. Okay? Let's do one more. So I gave you the line, I gave you the regression output, but I also gave you the residual plot. Do you see a pattern? Not really. It looks like it was almost one, but then there's dots at the bottom that messes it up, right? So there's no patterns. That means that this is actually appropriate. Okay? No pattern, appropriate. Pattern, inappropriate. Okay? Do I have any questions about residual plots? All right, now let's move on. Let's talk about correlation and regression wisdom. These are the last slides. This part is going to discuss what happens when we have influential points. So, what we do know is that in order to talk about R, which is our correlation, R has to deal with a linear relationship. Notice how we have different relationships. Some are linear. So the first one, we have a linear relationship. The next one is giving us a parabolic or a parabola relationship. The next one, notice how it's a straight line, but we have 2 points that are kind of out of whack. Notice how those 2 points changed it from being 1 to 0.8. So that's what we're going to be learning about today. And lastly, if those went all the way straight up, they gave you the same R. So that's a reminder to you that R is only for linear relationships. And once you get a point that is out of line, it'll change your R deeply. Okay? So here's some items that you need to know. I want to tell you about the difference between high leverage and outlier. Write this down. High leverage is if it has a greater X. High leverage, larger X. I'll say it one more time. High leverage, larger X. An outlier, larger Y. High leverage, X. Outlier, Y. High leverage, X. Outlier, Y. And based upon where they're located, both of these are called an influential point because that one point changes everything. Okay. So once again, class, high leverage has a higher what? And outlier has a higher Y. Great job. So the reason why that's important is because correlation, so your R and your least square regression line, they are not resistant. What that means is if you have an influential point, it will change R and it will change your least square regression line. So if I can show you these two graphs, if you look at child 18 and child 19, notice how child 18 has a similar Y, but it's all the way over to the right. So if we take a second and we stare at this data, this is the age that people had. This is the age that people had their first word and also their Gesell score. So child 18 had a score that was going along the same path, but their first word happened at 40 months. So their first word happened when they were around 3, where everyone else had their first word around 1 and 2. Now child 19 had their first word around 1 and 2, or 10 and 20 months like everyone else, but their Gesell score is a lot higher. So child 18 is a high leverage point. Child 19 is an outlier. Okay? High leverage means that your X is larger or a lot smaller, depending on which way you're looking at it. And an outlier means that with everything else being the same, that Y value is a lot higher or a lot lower. So child 18 is high leverage because the X value is much larger. Child 19 is an outlier because it falls outside of the pattern, and the residual, the Y value, is a lot higher. All right, so let's look about what happens if I take away child 19 or child 18. So if I take away the point for child 18, meaning you guys can just cover it with your finger, move it out the way. If I take away child 18, that means that my regression line is now going to shift upwards. We no longer need child 18, so we're not going to try and meet it with our least squared regression line. The y-intercept becomes smaller. So for instance, if y'all are here, you can take a look at me. Let's say you have a regression line like this, right? If child 18 is right here, this is what's happening to your line. It's evening out. Okay? So your y-intercept is getting smaller. Also, it's getting less steep, so your slope is smaller as well. Okay? Is that okay with everyone? What that also means is that the standard deviation, the variation of the residuals, are going to increase slightly. So the variance is a little bigger. But that also means that your line is now stronger. So your R squared, your line is a little weaker now because we have that child 19 right here, right? So if child 19 is still here and child 18, which was down here, is no longer here, that means that your line has to become weaker in order to account for your outlier, but not account for your high leverage point. So that means that it's weaker. So your R squared, which is just R squared, is weaker, is smaller. But that also means that how far things are away, the standard deviation, the distance, is larger because now we're trying to account for everything else. Okay, last one. Now let's say we get rid of child 19. Let's say we get rid of the outlier. If we get rid of the outlier, so for instance, y'all, take a moment and look at me one more time. We have this line, right? This line is accounting for this outlier, correct? If this outlier is no longer here, my line can now shift closer to everything else. So this line is not going to do this, because now it's going to try to account for your high leverage point. So your slope doesn't really change. Neither does your y-intercept. The standard deviation is a lot smaller because remember, child 18 was along the line for y's. It was the x that it wasn't. And it also means that it gets stronger. Your r is stronger. So if you square a higher r, you have a higher r squared. Okay. Does anyone need me to do that again? Or would you like me to graph it? Silence? Oh, my crickets. Okay, I'll do it one more time when I get out of here. So here's the last thing I want to remind you. Association does not imply causation. So just because something is associated does not mean that that is the answer to the reason why something is happening. We can only say, oh, they're associated. There's something here. So just keep that in mind. We want to show that our explanatory variable causes changes in the variable, but for this chapter, we can't prove that. So just keep that in mind, all right? That is all, humans. Welcome to the end of chapter 3.